To understand the atomic structure, let's take a look at carbon. Carbon is written as C in the periodic table. The number 6 represents the atomic number. It is the number of protons. Number 12 represents the atomic mass, which is the number of protons plus the number of neutrons. We can use this information to draw the atom. The protons and neutrons are in the nucleus, 6 protons and 6 neutrons, and the 6 electrons are located in the shells. The first shell can only hold up to 2 electrons, and so the remaining 4 electrons are in the second shell. And the nucleus contains the weight of the atom because the protons and neutrons are heavier, much heavier than the electrons which are in the shells. We have just seen an example in which the atom has equal number of protons, neutrons, and electrons. What happens when the number of neutrons is different? In the first example here, the atom has equal number of protons and neutrons, which is the carbon-12, the example that we saw earlier. What happens when the atomic mass is different? Then you have 6 protons and 7 neutrons because the atomic mass here is 13. The number of electrons stays the same, which is the same number as the number of protons. Here we have carbon-14 with 6 protons and 8 neutrons, and the number of electrons again stay the same, which is 6 electrons. So an isotope is formed in each of these cases. An isotope is an alternative form of an atom with a different number of neutrons. In order to draw an atom, we need to know the electron arrangement. There are some rules to follow. Now here is our carbon with its 6 protons, 6 neutrons, and 6 electrons. The inner shell holds up to 2 electrons. That's the first shell, holds up to 2 electrons. The second shell holds up to 8 electrons. So the first shell up to 2 electrons, second shell up to 8 electrons, the third shell up to 8 electrons. Let's apply the rules of electron arrangement to oxygen. Oxygen has 8 protons, 8 neutrons, and 8 electrons. So let's draw oxygen. That's 8 protons, 8 neutrons. Now how do we arrange the electrons? According to the rule, the first shell holds up to 2 electrons. So we have 2. So we have 6 remaining, and those will go in the second shell. The second shell holds up to 8 electrons. So we now have 6 in there. So 6 plus 2 is the 8 electrons. Let's recap what we know about protons, neutrons, and electrons. So what do we know about a proton? We know that it is positively charged. We also know that the proton is located in the nucleus of the atom. A proton weighs 1 atomic unit. The proton determines the identity of an element. So if we change the number of protons, you're changing the entire atom. So it determines the identity or the ID of the element. Let's recap what we know about neutrons. A neutron has no charge. The neutron is located in the nucleus of the atom. The neutron weighs 1 atomic unit. If you change the number of neutrons, you create an isotope. Let's review what we know about an electron. An electron has a negative charge. It is located in the outer shells. An electron has no weight. If you change the number of electrons, you create an ion. An ion is basically a charged atom.